Okay, today we are going to take those cosine and sine functions and we're going to move them up and down, as well as yesterday how we stretched it horizontally, stretched it vertically, flipped it upside down. So that's what we're going to do today. You really need to take your time and make sure you cover all the different characteristics of the graph, and that you're not missing a part. Like, you're not missing that it needs to be flipped, or you're not missing that the period is shorter and it needs to be scrunched together, something like that. So really take your time. I'm going to show you how I do it, just to make sure I don't miss anything. You may have a different way of doing it. If you like to put your original like cosine or sine function, if you want to draw two graphs on one, like if we're talking about cosine and you want to go ahead and put the original cosine on here, you can do that. You don't have to, but it's whatever helps you graph the new function and not miss anything. So I'll just kind of go through it. I'll show you how I do it, and hopefully it'll make sense, and hopefully it'll help you graph too. So we're going to look at our equation. Now this is kind of like parent functions that we talked about at the beginning of the year, where we moved it up, down, left, right, stuff like that. If it's inside the parentheses, it's going to move it left or right. It's going to move it on the x-axis because it's with the x, right? And the x is left to right. So we're talking about a horizontal shift on the x-axis. So that's going to be the number inside the parentheses, and it always does the opposite of what you think. So if it says -3, that means we're going to move it to the positive side. We're going to move it to the right. If it says +3, we would move it to the left. The number at the end is going to tell you your vertical shift, up or down. So if it's +1, it's going to move it up 1, minus a number is going to move it down, just like any other function. So let's start with this one. We'll start with baby steps, and then we'll slowly work up to changing the amplitude, changing the period, up, down, left, right, flip it, all in the same graph. Okay, but we're going to work our way up to it, because there is a lot to think about whenever you're just drawing one little curve, you know. So on this one, the shift on the vertical axis, that's our x. Okay, so our vertical shift would be here, that x -3. So it's going to shift 3 units, and it's going to go to the right. And before you graph anything of the new function, go ahead and fill this out, fill in your questions, and kind of get a game plan together on like how you're going to graph it. Your horizontal shift, oh, I'm sorry. That 3 units to the right, that's your horizontal. Oh yeah, horizontal is left to right. Vertical is up and down, so my vertical shift would be up 1. And if you wrote it on the line that I did, it's not a big deal as long as you know how it's moving. We're good. But I'm sorry about that. So vertical shift is up or down, horizontal is left to right. Your amplitude is going to be the number at the very beginning, the absolute value of that number. And here we don't have a number, so it's a sneaky 1. My period would be 2 pi divided by the number in front of x. And on this equation we don't have a number in front of x, so it's a sneaky 1. And 2 pi divided by 1 is still 2 pi. All right. We're going to wait on the domain and range for a second. Now, your amplitude is normally from -1 to +1, right? Your wave goes up to 1, down to -1, and it keeps repeating. So what I like to do, and I talked about it a little bit yesterday, I like to make boundary lines, so I know where my max is and where my minimum is, and it's kind of just one less thing to worry about, because there's a lot to think about here. Also, your period is normally 2 pi. That's a full revolution. So your period didn't change, your amplitude didn't change. What did change was that we're moving it up 1 and right 3. So what I do whenever I draw my amplitude, the little dotted lines, I go ahead and take into account that I'm going to move it up 1. So I'm going to take my max, which is normally at 1, and I'm going to move it up 1 more. So it should be at max 2. My minimum is going to move up 1, and now it's going to be at 0. So go ahead and draw your dotted lines at 2 and at 0. That's where your new amplitude is going to be. Okay, that also tells you what your range is. My minimum is 0, and my maximum is positive 2. So I'm going to fill in my range. All right, so normally your cosine starts out at the top and then goes down, right? And we aren't flipping it at all, so we still want to start out at the top, but we need to move to the right 3. So these little tick marks, I know it says pi over 2, pi, 3 pi over 2. If we're talking about whole numbers, we're going to use the same scale as your y is split up in. So like your y goes by halves, goes half, 1, 1 and a half, 2, 2 and a half, 3, right? We're going to take that same scale on the x. So it's going to be half, 1, 1 and a half, 2, 2 and a half, 3. So 3 is actually where this pi is, which is pretty close. Pi is 3.14. But just so you know, if we're talking about whole numbers, that's the scale that your graph is going by on this paper. Okay, so we're starting out at the top, but instead of starting out at 0, we need to move to the right 3. So we're going to go 1, and I'm skipping every other one here. 1, 2, 3. And that's going to be my origin. That's going to be my starting point of the cycle. Okay, so I kind of put an asterisk here so I know, like, this is where I'm starting out at. Not that there's going to be really a question on it because it's going to keep going on forever and ever. But for me it helps, especially when we start changing up the period and like smushing it together and stretching it out. For me this helps. Okay, because in 2 pi it's going to repeat. So at a distance of 2 pi, I should be at that exact same point, right? Now, it's going to be hard to go 2 pi to the right because we're going to be way off the graph. So what we can do is go 2 pi backwards, and it's still going to be at the same point because our cycle repeats. Okay, so 2 pi back this way. Let's see, we're starting out at pi, so pi to 0 would be a distance of pi, and then one more at negative pi would be 2 pi. So at negative pi, we're going to be back at the exact same point. All right, so the next thing I do is I say, okay, so I have the beginning of my cycle and the end of my cycle. Halfway in between that, for a cosine function, halfway in between, I'm going to be at the bottom of my amplitude, like the lower amplitude, I guess. Your minimum is a better way to say it. So halfway in between those 2 points, I'm going to be at my minimum. So I'm going to go ahead and draw that point. Now, halfway in between these 2 points here, the first 2 points, or even the second 2 points, I'm going to be in the middle. We call that the axis. I'll just call it the middle. So halfway in between, I'm going to be at negative pi over 2, and I'm going to be right here in the middle of my amplitudes, so at 1. At positive pi over 2, same thing. I'm going to be at 1. And you can see you have one full cycle. Okay. And now, once you get that one full cycle, it's a lot easier because you just repeat it. Okay. So go ahead and plot the rest of your points. After this beginning point that we drew, it's going to come back down to the middle, and then it's going to go down to your minimum at 2 pi. Okay, if I work my way backwards, I'm going to go back down to my middle at negative 3 pi over 2, and at negative 2 pi, I'm going to be back down to the minimum. So your graph should look like this. My domain, that wave kind of cycle is going to keep going on forever and ever. So my domain is going to be negative infinity to positive infinity, or all real numbers, either one.